So this lecture is for shaft design of shafts. In this lecture, we will apply the previous failure technique or failure analysis on shafts, both static and dynamic failure theories. Okay, for design of shafts, we need to consider a few points. First of one, selection of material, because material will decide on the strength of the shaft. Stronger material will give you more strength. That means you can apply more stresses and you get longer life. Geometric layout is the size, diameter is very important. And then stress and strength. This provides the static strength, the yield strength and ultimate strength, and fatigue strength, which is the endurance limit if you are looking for infinite life, or strength of failure for shorter life. Deflection and rigidity, to study bending, torsional deflection, slope at bearings, and so on. We will not focus much on the deflection and rigidity for shafts in this section. Then vibration due to natural frequency, something that must be considered, so you avoid resonance and you avoid the natural frequency vibration. Deflection is primarily controlled by geometry and not by material, and stress is controlled by dimensions, size, diameter, not by the material itself. Material can give you only strength. Material can control strength of the shaft. So usually shafts are rotating members. If shaft doesn't rotate, we call it axle. So axle is a shaft that doesn't rotate, but it supports members that rotate around its axis. In shafts, we usually use low carbon steel, either cold drawn or hot rolled, from any series 1020 up to 1050. Fatigue properties don't usually benefit from high alloy content and heat treatment in shafts. Also, you don't need any surface hardening for shafts unless you need a smooth surface. If you need to use the shaft as a bearing surface, then surface hardening is important to reduce friction and to improve surface properties. Again, cold drawn steel is typically used for smaller diameters, and for larger shafts we use hot rolled that can be machined all over. And the production method will depend on the quantity that need to be produced. For low production quantities, we can use lathe machine, and we design for minimum material removal. But for high production quantities, lathe machine is going to be expensive and not economical. So we use other methods. We use forming or casting, and again, the design goal is to use minimum material for the shaft. Shaft layout is very important. When you design a shaft, you need to consider the layout. You need to look at the forces, what forces are applied on the shaft, what axial components, what axial load is applied on the shaft, and what kind of torsion, the rotation, and so on. Another point is the assembly and disassembly. It must be accessible, it must be easily disassembled. If you need to do some maintenance or repair or to change any component, you should be able to do that. Okay, so shafts are used to transmit and support two things: load and torque. Load, usually axial load or bending. In axial load, shaft will receive some forces from components installed on the shaft itself. So if you have a bevel gear or any type of other gears, usually these gears will transmit axial and bending forces. So you need to support that force. You can support that force by providing location shoulders on the shaft. Location shoulders means change in diameter of the shaft, or retaining rings. So you keep the component in place using retaining rings, using pins, using trough bearing, and so on. Torque transmission is very important. And torque, to transmit torque, you need to make sure that the component that is installed on the shaft component and the shaft can make one rotating element. So they rotate together without you need to prevent any slide between the surfaces. That can be ensured using keys, splints, set screws, pins, and any form to make sure that the two members, the component and the shaft, are rotating together. Power, of course, depends on torque, transmission, and angular speed. So the formula here gives you the power in watts if you have torque in Newton meter and angular speed in revolutions per minute.